Yeah. So today we will discuss about jagged array. Important of this topic is you need to know how internally it will make your memory allocation and how does it make your accessing to your array. How does it access your data and how does it different from single and multi-dimensional array. That part we require to know. So important is architecture. Okay. Now, something important in this topic is jagged array is also called array of arrays. Jagged array is also called array of arrays. So why is it called array of arrays? What actually we have a process. We'll see all of those things. Second scenario is or second point is especially when I say jagged array, we are going to have data presentation in rows and columns where each row can have discrete column length. I mean to say different column length. That is what the aim of your jagged array. Okay, let's see how does it go. Now, let's take simple example that main method class, those will be same only. First, how do you create jagged array? So I say integer a1 equal to 1934. This is one single dimensional array. Again, integer a2 equal to 10. I have one single dimensional array with one element. Int a3 equal to 15, 23, 19. This is third single dimension. So it's now we have three arrays. How do you create a jagged array now? Int, you have to put two square brackets. In yesterday in double dimensional array and multi-dimensional array, I asked you to put one square bracket in which you have to put comma. If I put single comma, if I put single comma, then it is double dimension. If I put more than one, then it is multi-dimension. Yesterday. But here, no. Here we don't put comma, we put two square brackets. Then I say ARR is equals to A1, A2, A3. 3. Now, first we'll see how to create memory for this array. How does it work? How does it link? Those things we'll discuss. First, this is heap memory. This part is heap memory. And this is stack. Stack memory. Now, first you'll have ARR, where in stack, heap, stack, and this is heap memory. Now this is your array variable, and that array variable will have three locations. Yep. These are your three locations of your array variable. This is 0th row, this is first row, second row, 3. Obviously, respective index positions. Index positions are 0, 1, 2. 0, 1, 2. These are index positions of each row. 0th row, first row, second row, 3 rows. And then this is your variable ARR. And then you have second variable A3, A2, A1. 3 variables. Every variable has its own memory. This is to store reference of A3, and second is to store reference of A2, this is to store reference of A2, and this is to store reference of A1. 3 variables, A3, then A2, then A1. 3 variables. Now, first I'll draw 2 locations memory. This is memory for 2 locations, including references I'm representing. Okay, this is memory for 2 elements. Then we have memory for single element. This is memory for single element. And then we have memory for 3 elements. 3. 0th location, first location, second location. Every location will have its own unique address. 1001, 1005, 1009, 1013, 1017, 1021. These are the references. 0th location, first location, then this is second location, 0, 1. Okay, repeated. This is 0th column, and then this is also 0th column. This first column. References 1001, that will be available here. Then 1005, then 1009, and that 1009 will be available in A2. Then 1013, and that 1013 will be available here. Sorry, A3. Then 1017, then 1021. 1021. This is the memory. And what are the elements that you have is now important is in this architecture, we have to justify that why is this called array of arrays. That is another important task for us now, like 23, 19. So only for one example, I'll come up with the architecture, and whatever the other examples I cover, you have to correlate that every jagged array example internally presents data in the same format. For that reason, I'm trying to come up with this architecture. 10. 23. 19. Now indirectly, this A3 will point to this array. A2 will point to single element array, and this will point to this array. Currently, all are single dimensional arrays. Now, what will happen when you work with jagged array is this A1's address is there now. This A1's address. It is going to dump this. It is going to what? Dump this array one's address. So I mean to say A1's reference will be copied to 0th location of array 1. Similarly, reference of A2 will be copied to first location, and reference of A3 is copied to second location. Yes, so indirectly now you can say that 0 will have 1001, then 1009, 1013. Yes, because three references of single dimensional array has been clubbed into ARR 1009, 1013. Yes. Now what happened, internal, what will happen? These three arrays are now clubbed. These three arrays will be clubbed now. They all are clubbed. All are clubbed. Mhm. Now, what is that you have now? Indirectly, now I can say that this 1001 is pointing to this memory. This 1009 is also pointing to this memory, and 1013 is also pointing to this memory. Now, if you compare 3 points, this is what we learn. This is one array, first one, this first one. This is one array, then this is another array, and this is another array. Three arrays you can see. Three arrays. And all these arrays are clubbed now. So I'll just link properly. Okay, this is one array. Okay, this is another. So all these three together, they become what? Arrays. All these three arrays. Okay, and all these arrays are clubbed together. All these arrays I'm saying, they are clubbed together, and when it is clubbed together, it becomes array of arrays. That is what the topic is for our third type of array. What are these three called, you said? What are these three called? Arrays. And how do you club them? All are clubbed as one array. Here, let me write now. Three single dimensional arrays. Yes. Here. Three single dimensional arrays. You are trying to club to what? Array. Array of arrays. I'll write here. All these three together are arrays, and this array are connected or are grouped. All are grouped as one array. It's called array of arrays. That is how it works. Okay, now something important is accessing. This is how internal jagged array is represented. Now that's what I was saying now. Any example program I do on jagged array, you make yourself convenient that internal, like this only, it will represent your array architecture. Okay, now coming to first console dot write line, I say rows equal to plus arr dot length will return three rows. Now for int index equal to 0, index less than arr dot length, index plus plus. If you recollect my last session, you could very clearly see in double dimensional array, when I say arr dot length, it was returning number of elements available in the array. Then we said get length of 0, get length of 1. Then they were returning number of rows, number of columns. But here in jagged array, array dot length makes what? Number of rows. And each row is with discrete column length. Discrete column. So do one thing. First we'll display length of each array. Console dot write line, columns is equal to plus arr of index dot length, semicolon. Now this will display arr of 0 dot length. Answer is two columns. Then ARR of one dot length, one element. ARR of two dot length, three elements. So you'll get columns 2, column 1, and columns 3. 3. You want to display elements also. Those elements also you want to display. Then you have to write if you want to display them. For int, here better I say, instead of index, you say row equal to 0, best, row less than, row plus plus. Here you use the word column equal to 0, column less than ARR of row dot length, column plus plus. Here IND I should remove, I write row. Okay. Now you want to display also now. Console dot write ARR of row, column plus blank space, console dot write line. Yes, over. Number of rows available are 3. Each row has discrete column length. Over. That will return you with number of elements. Length also it will display, plus elements also it will display. One way of accessing. Second way of accessing, I can write for each loop also. For each. Where are your elements? Where are your elements? So elements are in ARR. Elements are in ARR. And how the elements are? Each row has different column length, but they are single dimensional. So I have to create int x. So now you can say from ARR, one row element, it is going to extract and put into X. From ARR, one row element, it will extract and stores into what? X. It means array of 0 has 2 elements. Those 2 elements it will bring and store into X. Again, array has first row, 1 element, X will be containing 1 element. Then 3, X will be containing 3 elements. Then 3 times it will process, and each time it is going to get the array of different length. You want to get one element of X now. Again I write for each int y in X, console dot write y plus blank space, console dot write line. That's it. Copy this. Then go to Visual Studio. Now we'll dump the code. That's 60. Yes. All the semicolon. How many elements you have now? 19, 34. 34. A2 equals to A2 containing one element, 10. A3 equals to 15, 23, 19. That's three elements. Now you want them to be clubbed again in two square brackets. ARR, A1, A2, A3. Three elements. Now if I run, you can definitely experience all the things whatever we just now said about this jagged array. Control F5. Two times you'll be printed by the element. Rows 3. Each row has different columns, and after displaying column length of each row, you can find even below it elements are also displayed. Okay. For each loop also has worked, and index positions also have worked. Two different. You want to segregate them, just draw one line so that you can make clear for you. Console.write line. Control F5. Not perfect. For each loop output, for index positions output, row column index position. Well, this is one approach of jagged array. Second part, I won't disturb this accessing part. Then remove this. Now another approach. Integer ARR equals to new integer, 3 rows, block open. New int of 5 equal int of 5, then element 1, 2, 3, 4, 5, comma. New int of 2, then element int of 2, then element 8, new int of yes. Now what did you do? We created jagged array, and remember another important point of jagged array is whenever you create jagged array, specification to specification of size to rows is optional and column size never specify. You should not provide size for columns. Never, never, never. Row size you give, that too interested you give, otherwise you can skip off. But column size never we provide, never. There is no way of specifying column size. No way. Only row size is provided. Okay. Now, how do you read this?
So this five, two, three, all these three are column size only, right?
Which one? No, column size. Yeah, exactly.
Five,
Column.
two,
Yes,
three.
yes, column size. But where you are providing, there internal to JAG array we are
Visualize.
providing. Here you are not providing. Here,
Mhm.
JAG array memory when you're creating here.
Okay.
In the three, you didn't give any size here.
Only rows.
Ah,
Yes,
you are
yes.
covering. You are providing column size memory internal of JAG array.
Okay.
And here you see these rows are there, no? Three I gave. No, don't give. Doesn't matter. Valid. It is valid. Only the way you read is it will now you have to read like this. Supports to create any number of rows, and each row can be of discrete column length. If I put three, now you read supports to create three rows, each of whatever specified column length. One of five, one of two, one of three. Now when I display, when I execute, same output. Yes, three rows. First row, column, five columns. First row in the sense zeroth row, five columns. First row, two columns. Second row, three columns. You want to display that also? You can write here like this. You can say what you can say is row, no, row plus row plus has plus columns. Oh, control Z. Hmm. Row 0 has this part I have to write here. ARR of row dot length. Cut this, paste here, put plus. And here you don't need to give. That's control KD. Now I'll run my code. You can read out what exactly. Yes, row 0 has 5 columns. Row 1 has 2 columns. Row 2 has 3 columns. Here equal to I'll remove. And I'll have a separator here just for understanding. Yes, right. Another approach. Now, this time what I will do, I don't want to go with initializers. No, I'm not interested. Rather, I say row 5 rows. You create jagged array of 5 rows. Now, what do you want to do? Only rows memory. Stack has only 5 rows memory, no columns. Now, what is your aim now? Each row should have a different column length now. Each row. So now we should write a logic now to allocate memory for columns. For that, I say int row 0 row less than arr dot length row plus plus. Okay, so this is going to work for 5 times because arr dot length is 5 now. So this loop is going to work for 5 times. Now you say arr of row with the 0th row equal to new int of row plus 1. So it means initial row is 0. So it is going to allocate memory for 0 plus 1. Then 0 plus 1. Then you'll have 1 column memory. Then 2 column memory. Then 3 column memory. like that. Or else you can do like this. Your row will be suitable because this logic is going to work for number of rows. This logic. Each row will have one extra column. Row zero like it will create a shape of triangle. If I run, you can check now. Zero, all zeros you'll get. First we'll have zero, then zero zero, then zero zero, triple zero, 40, 50. Each row is allocated by one extra column memory. Each row. And there is a program. This is a program. Zero will have zero plus one, means one column memory. Then one will have two columns memory. Then two will have three columns memory. Then three will have four. Four will have five. Every row will be provided with one extra column memory. That is what happens in that statement. But now what is my aim is, I want to decide at runtime how many columns memory that I need. I want to decide at runtime. Decide at what runtime? What do you want to decide at runtime? So that you are going to input different column lengths at a different execution. How would you do? Row plus one is there, remove and write. Int dot pass console dot read line. Yes, run the code. Now it will ask waiting. Input now. 8, 5, 2, 7, 3. Enter. Yes. Row 0 has 8 columns, row 1 has 5 columns, row 2 has 2 columns, row 3 has 7 columns, row 4 has 3 columns, elements, respective rows, respective elements. So is this fixed? No. If I run for second time, again it is going to ask me. Again I may give different elements. Every time I may have different column length for each row. That row plus one, the statement that was there, simply I replace that row plus one with input statement. So that you could see that in every execution it is going to ask you 5 elements. Those 5 values are nothing but those 5 values will be used to allocate memory for columns displayed. That's it. Each row n columns. Okay, now what we will do, now we are going to see fourth example. Now I'm going to create jagged array of only 3 rows, and I want to have columns in each row. That is also fixed only, 3 columns only, means 3 rows, 3 columns. I want to create now 3 by 3 matrix, and then we'll see what next to do in same. So what I should do, 3 rows only, 3 rows. Okay, column memory, not input, not in increasing point, just say 3 here. Yes, each row 3 columns. If I run now, over, that's it. Control F5, fixed memory, 3 rows, 3 columns. Yes, 9 zeros. You want to find You want to input data, then to input data, I write this for loop. If you want to input data only, if you are interested to input data, then only I'm saying. Otherwise, same, you know already the double dimension with the way I input, same way you have to try here. ARR of row column is equal to int dot parse console dot read line. Over. That's it. Okay, we'll try. No problem. Just simple program. I'll remove this. Now, copy this for loop. Copy this inner for loop. Now you should write ARR of row column equal to int dot parse console dot read. But that's it. You want to find trace of a matrix? That is also fine. Take one variable here. Int sum equal to 0. Sum plus equal to ARR of row and column. And only when row and column are equal, it should do this. Best over, done. Last name, you write. Last name, somewhere here I write. This I should remove now. And I should put this here. Okay, and last name, I should write console dot write line. Trace of matrix. Let's run the code. However, you'll get 0 only because I didn't. Inputs are there. No? Okay, anyways. Inputs are there. I'll give one below this. 10, 20, 30, 40, 50, 60, 70, 80, 90, 150. Sum of principal diagonal elements. 150. You want to print using for each loop? That is also fine. Printing through for each loop. Remove this. You don't want to display like this. No. You don't want this console dot write line. Then here to print I'm writing to print for each integer x in ARR for each int y in x. Now run the code. Now we don't need that also. Once again, I'll close that window. Now, why unnecessary this now? No displaying of rows, number of things. Just it should go. I'll close this. Chalo, right. Now run the code. Control F5. See, by seeing the output, you can make your things input now. 10, 20, 30, 40, 50, 60, 70, 80, 90. Yes, 90 plus 10, 100, 100 plus 50, 150. Trace of matrix for jagged array. For jagged array. Now, I give you one technical program on jagged array. Same, already I have explained you, only you have to write another logic for that. Same, trace of a matrix only. But approach I want to change. What is the approach? Fine. So here I'll make a query. This is actually a technical query. You just try to work on it. First, write a program to create jagged array of 3 rows and 3 columns. Input elements into array through command line argument. Find the trace of a matrix. Second point is very much important. You don't use readline. Console.readline is not, don't use. Rather, I'm asking you to input elements through command line argument. That is what I want you to do. Input elements through command line argument. And finally, whatever inputs you give, find the trace of a matrix. Total logic is here only. Here. How do you input elements through command line argument? It will be very interesting. Go for it so that easily you can make it. And you can do all programs on it. Matrix multiplication, addition, all programs you can do. Whatever we did there in double dimension assignments, what I guess, same you can convert to jagged array. That's it. This is your jagged array. Tomorrow, before I start OOPS, as you asked me to go with some examples on while loop, if conditions for loop. So those things
Yes,
tomorrow class I'll explain. After that, we'll go with the OOPS introduction. We are done with all the basics of C#.
Hmm.
Okay.
Okay.
Yeah.
See you.